All right, hi. Happy Monday or whatever day it is that you are watching this. Um, I hope the factoring quiz went well, and now we're going to start chapter 3. Um, so, chapter 3 is solving quadratic equations. We're going to continue on with quadratics here. We're not going to move on quite yet. We still have some stuff to learn about them. In chapter 3, if you can't tell by the title, is all about solving quadratics. We've graphed quadratics, we've kind of manipulated them a little bit and used them to solve some application problems, but now we're going to solve them, okay? And in order to solve quadratics, we have to first understand how to simplify radicals. There were some on that worksheet that I handed out, so let's just go over some of these. There's 2 schools of thought. I'm going to show you the first way, which I think is a little bit easier, and it's making a factor tree. And so when you're making a factor tree, basically what's going to happen is that you are going to break these numbers down into factors. So like the factors of 24 are 2 and 12. You could have also chosen 3 and 4. There's nothing wrong with that. 2 can't break down anymore, but 12 can. So you can go to 2 and 6. 6 goes down into 2 and 3. Okay? That's the idea of a factor tree, is that you break them down. And because it's a square root, you're looking for pairs of things. So you can circle pairs, which is 2, you bring a 2 out. And what's left underneath the radical is what you have left, which is a 2 and a 3, and you're going to multiply them together to be 6. So the square root of 24 actually simplifies to 2 times the square root of 6. That's how I like to do it. Now, there are other people that say, well, what's a perfect square that goes into 24? And the biggest perfect square that goes into 24 is 4. And 4 times 6 gets you to 24. And then people say, okay, well, the square root of 4 is 2. And then you're left with the square root of 6. It doesn't matter to me what your school of thought is on it. I personally like factor trees because of reasons that you'll see later. But there's nothing wrong with thinking in that method either. Okay. So for B, I always like to, if it's even, start with 2. I'm not really sure why I choose to do that. I just know that any even number is divisible by 2, so that helps. And then 108 divided by 2 is 54. Okay, and then 54 breaks down into 2 and 27. 27 breaks down into 9 and 3. And 9 breaks down into 3 and 3. So we're looking for pairs of things. There's a pair of 2s. There's a pair of 3s. So you can pull both of them out. You've got a 2 and a 3. And what's left underneath the radical is whatever doesn't have a buddy. And 3 doesn't have a buddy. So there we go. And then we, of course, have to simplify. 2 times 3 is 6. And then you're still left with the square root of 3. Okay. I'm hoping this isn't too much of a shock for you. C looks a little bit different, but it's handled the same way. 80, just for funsies, let's break that down into 8 and 10. Okay, 8 breaks down into 2 and 4. 4 breaks down into 2 and 2. 10 breaks down into 2 and 5. So the pairs that you have are 2s. You got 2 2s, and then a 5. So we can't forget about this 3 here. All right, that 3's got to come along. You have 2 2s, so those both have to be included. And then you're still left with the square root of 5. Okay, so 3 times 2 is 6, times 2 is 12. So we're left with 12 square root 5. That's where we end. Beautiful. Let's see. D is the square root of 98 here. Actually, your D is different. Your D is the square root of 324. So you don't have this one. My bad. I included some things that were a little different. That's okay. So you're actually working on the square root of 324. Now you could into your calculator. The reason why we're not plugging these straight into our calculator is if you notice, let me pull mine up here, applications. Okay, if you were to plug this in, you would have the square root of, let's try the first one of 24. The reason why this doesn't work is it gives you something like that, and that's really nice, ugly. And we don't really want things that are ugly. We like things that are pretty. So that's kind of why we're doing this. And you should have done this in geometry. So for 324, I broke it down into 2 and 162. 162 broke down into 2 and 81, and that works out nicely because that's 9 and 9. And if you notice, you have a pair of 9s and a pair of 2s. So 9 times 2 is equal to 18, okay? And you don't have anything left, so 18 should be the square root of 324. Let's see if that's actually true. Well, you've got the square root of 324. Oh, excellent. That's awesome. 18. Beautiful. Okay, so sometimes it'll work out like that. On this next one, same thing. 648 breaks down into 2 and 324, which, if you caught this, did you catch it yet? How about now? Oh, yeah, that's right. It's exactly what you just did. 324 breaks down into 18 and 18, because that's what we just learned from up in that example. So you have a pair of 18s, okay? You can't forget about that -2. So you've got -2 times 18, and then you still do have a 2 left there underneath the radical. Can't forget about that. Then you just multiply, and you get -36, square root of 2, circle it, donezo's. Okay? This last example, which is example F for you, not G, but F, is interesting because if you try to make a factor tree of 22, you get 2 and 11. And so, and 11 and 2 are both prime, and so there's really nothing that you can do to break them down from there. And so in this case, you would just jump back to what you originally had, to the square root of 22, and then you're done. Okay. All right. So that, again, should have been review. Hopefully nothing crazy there is occurring. Okay. Okay, so a quadratic equation in one real variable is an equation that can be written in standard form. We've talked about this already. Nothing of that should shock you. Again, a cannot be 0 because then if that's 0, then you don't have a quadratic. You have something that's linear, and we're past linear because now we're in Algebra 2. Welcome to the big leagues. And so we call a root to be a solution. So a root and a solution are kind of synonyms of each other. So if I ask for a root, I mean a solution. If I ask for a solution, I mean a root. There's also a third word that we could use, and it's called a zero. Okay, and we'll talk about that as it comes along. And there are 3 methods in order to find the solution to a quadratic. The first is graphing. Okay, we're going to do that first. There's a square root method, and we can also factor, hence why you had a factoring quiz. Okay, there's more methods, but these are the only 3 we're going to cover in section 3.1. This whole chapter is about methods on how to solve quadratics. So these are the 3 that we cover first, and then we'll cover more in the sections to come. So I hope you can sleep. I know it's super exciting, but it'll be fine. Okay, so here's the graph that we got going on. That's a quadratic in standard form. But now if you notice, you're set equal to 0 and not equal to y. That's the main difference here, okay? And so what I want to figure out is where this quadratic, where this parabola, is equal to 0. Well, it would probably help if we drew a picture. Now here's what I suggest. You could go through and do all that stuff by hand, finding the vertex and blah-de-blah-de-blah, or you could use this really, really awesome thing called a graph calculator. And you could go to y equals, okay, and plug that in. So you have x squared minus x minus 6. Go to your graph, and it should pop up. Oh, that's nice. And don't just guesstimate what's happening on that graph. There's this really handy-dandy thing called a table, and you can plot points. You're welcome. Great. And so if we go to our graph and we plot those points, because I already have them figured out, one of them was -3, 6. Another one was -2, 0. You had -1, -4. 0, -6, right down here. You had 1, -6. You had 2, -4. And then 3, 0, and then 4, +6. And you could draw your parabola. If you notice you're missing the vertex, but that's okay because the vertex is going to happen somewhere in between here. So you can just guesstimate where you think halfway in between would be for that shape. And then you try as best as you humanly possibly can to draw a super pretty parabola. You connect all the dots. Again, they didn't teach me this in college, so I'm doing my best as well. That's a parabola. Not pretty, but it's great. And we want to know where that parabola is equal to 0. Well, if you sit there long enough, and you're like, okay, well, where's y 0, right? Because instead of y, normally it equals y, but I want to know where y is 0. Well, for those of you that understand graphing, y is 0 on the x-axis. Are you shocked? Good. So we're looking at the x-axis. In other words, we're looking to where this graph crosses the x-axis, which is here and here. So the solutions to this is that x is equal to -2 and x is equal to 3. So for those of you that are like, what does that actually mean? Let me tell you. This means if you plugged in -2 or you plugged in 3 to these x's right here, now it has to be the same one every time. So you would have to plug in -2 for both of them or 3 to both of them. You would end up to be 0. So that's a really good way that you can check your work is to plug it in. Does your equation make sense? Okay. Great, let's do one like that. All right, so this one, there's a little bit of a problem. And it's not really a problem, it's just kind of an extra step that you have to take. Your graphing calculator, if you go to y equals, only graphs if y is by itself, right? And right now we have things on both sides, and there's ways that we can handle it. And the first way that we're going to learn to handle that today is, well, let's just set it equal to 0. Right? If you don't know how to do something in math, make it so that you do know how to do it. And we can do that by subtracting 4x from both sides. And when that happens, you end up with -2x squared minus 4x minus 2 equals 0. It's the same thing. You can do that. That's fine. You can move things around. Okay? And then because you're really good and really smart, you're going to go to y equals. Oh man, that's not what I wanted. You're going to go to y equals and you're going to plug in -2x squared minus 4x minus 2 and hit that graph to kind of see what it looks like. Graph some points. Okay, so that's kind of what we're going to be drawing. To find the points that you actually want to draw, you go to second graph, find that table, and plot those points. So you've got -1, 0, -2, -2, 0, -2, and then it's like 1, -8 or something like that. I don't really have those points exactly written down. As long as you have 3 points on your parabola, you're probably going to be okay. So that's what our parabola looks like. And we want to know, again, where does this graph equal 0? So where's y is 0 and y is 0 on the axis? And you can see from this graph that it only occurs once, and that's at x equals -1. So we only have one solution this time, and that can happen, friends, obviously, because I just showed you. And so that means if you were to plug in -1 to that parabola right there, or to that equation, excuse me, the quadratic, you would end up with 0. Don't believe me? Try it. Do it. Do it now. Okay, great. I'm sure you all did it. All right. One more example like this. All right. I like to move everything so that the x squared is positive. Don't you? Me too. And so I don't know why the fraction bar is not showing up. That should be 1/2. I'm going to move the 6x over, and I'm going to add the 20. So that you're left with 1/2 x squared minus 6x plus 20 is equal to 0. Boom. There we are. You plug it into the graphing calculator. Pretend I did it. Here's what it looks like. Okay. You're going to have a point at 6, 2. And then it looks to me like there's some points at some decimals right above there. There's also a point at 4, 4. And then there's also a point a little bit above the 6 right there. Okay, I only know this because I've done it already, so if you haven't, I would highly recommend you plug it in just to look at it. There's your parabola. You don't see all of it, but that's okay. You're never going to see all of a parabola, but that's fine. And what we're looking at right here, so we want to figure out where that equation is 0. But if you notice, it doesn't ever reach that x-axis. So we have a problem. And whenever we had a problem like this in math class, we had this really awesome thing that we did. We started and we said, normally you would say no solution, but now I'm going to enter this really strange word called real, and there's no real solution. And yes, you do have to have that word real, because no solution and no real solution mean different things. And when we get to section 3.2, you're going to understand why there is no real solution versus no solution. Okay? Great. That means that there is no real number that you could put in for x and make it be 0. There is an unreal number. Unreal numbers, by the way, are called imaginary numbers, and we're going to learn about those later. Contain your excitement, please. Okay. Great. That's graphing. Method 2, square root. As you can probably tell by context clues, because you're intelligent humans, we're probably going to take a square root at some point. And so if I just handed you this problem, and I said to you, solve for x, well, my Algebra 1 kids are getting really, really good at knowing that solve for x means get x by itself. So let's do that. To get x by itself, the first thing that I would do, I don't know about you, is I would add 31. I would add 31. So you're left with 4x squared is equal to, well, 49 plus 31. I wonder what that could be. Oh, that's probably 80. Yeah, you're probably right. Okay, so we got 80. That's nice. Okay. And then to get x by itself, we need to divide by 4. Divide by 4. So that leaves you left with x squared is equal to 20. So that's helpful. Okay. And to get x by itself, well, we got the obnoxious exponent of 2, and that's a square. And hopefully by now you understand that to undo a square of something, you just square root. Okay? And so x equals, okay, now here's where you have to be careful. Ready? Whenever you physically take the square root of something like we did here, you have to have this fancy thing called plus and minus, right? Because if I asked you, what's the square root of 4, you would probably tell me 2, and it is. Except that what happens if you take negative 2 and square it? Well, that also gives you 4. So if I asked you for the square root of 4, it could be 2, or it could be negative 2, right? So anytime that you physically take the square root like we did here, you have to have a plus and minus. You have 2 answers. Okay, similar to this one right here, you had 2 answers there. That's kind of what's going to happen here. Okay, so you have plus or minus the square root of 20, but we can't leave it the square root of 20. We do have to simplify. 20 breaks down into 4 and 5. 4 breaks down into 2 and 2. That is a pair. So now x is equal to plus or minus 2 times the square root of 5. And that is how you leave it, just like that. Okay, nothing fancy there. So that's helpful and nice. All right, let's do another one. Let's do B. B looks pretty. I would suggest subtracting 9. Subtracting 9. So you're left with 3x squared equals negative 9. And if we want to get x by itself, well, I would highly suggest dividing by 3. Dividing by 3. So that's pretty. And then you're left with x squared is equal to negative 3. Okay. And then to get x by itself, you should just square root. So x equals, well, hopefully you recognize that there's a problem here because you can't take the square root of a negative number. You don't know how to do that. Square roots of negative numbers don't exist, right? That's what someone has told you. So when something doesn't exist, we put that star and we say, all right, well then there must be no real solution here. And you're right, there's no real solution. Okay. Beautiful. Let's look here. Oh no. It's okay. We can work on it. All right, so this is a little bit different, but we can still work on it. I don't really like fractions, so I'm going to get rid of the fraction. And I can get rid of the fraction by multiplying both sides by 5, right? That's legal. So when that happens, you're left with 2 times x plus 3 squared equals 25. Okay, so that's a really great start for us. Okay, well, those parentheses are protecting what's inside with that square. So we have to get rid of this 2 on the outside, and we get rid of that 2 by dividing by 2. So now we're left with x plus 3 squared equals 25 over 2. And you're like, well, that ain't pretty. It must be wrong. No, it's not. It's right. The book said so. Okay. Okay. So now you're like, well, should I subtract 3? Not yet. You got to get rid of that square first. It's still there. So if we square root, you have x plus 3 equals, okay. Well, anytime you take a square root, you do need a plus and minus. That's always important. And there was this really old smart dead guy that found out that if you take the square root of a fraction, that's the same thing as taking the fraction of square roots. Okay, so then we're left with x plus 3 equals plus or minus. Well, the square root of 25 is 5, and well, we can't really do anything with the bottom, so we leave it the square root of 2, except you should have had some teacher tell you that that's not okay. You cannot have a square root in the denominator, and so we did something called rationalizing the denominator, where you multiplied the bottom by whatever that was. And that would have left you with x plus 3 is equal to positive or negative 5 square root 2 over, that ended up being 2. If you have issues rationalizing denominators, I would highly recommend that you go to YouTube and watch videos on that. Okay? All right, so we're almost there, but x is not by itself, so we need to fix that. We still have a plus 3. So just like normal, we'll subtract 3, we'll subtract 3. So your final answer is x equals plus or minus 5 square root of 2 over 2 minus 3. And that is your answer. It doesn't look very pretty, but that's okay. That's how we roll with that. All right. Okay. Man, more examples. This is fun. All right, on D, let's see. I would subtract 14 first. I don't really know about you. Minus 14, minus 14. You've got 2/3 x squared equals 6. I don't really like fractions, so let's get rid of them. Times 3 times 3. So 2x squared is equal to 18. To get x by itself, we got to divide. So then we're left with x squared equals 9. Oh, isn't this pretty compared to what we just did? When you square root, x is left with 3. Or remember that plus or minus idea? That's what that actually means, okay? So when you have x equals plus or minus 3, that means that x could equal positive 3 or x could equal negative 3, okay? And if you're like, Ms. Baucom, how do I know if I'm right? Well, you can plug them into that equation right up there top, and it'll probably work for you, okay? Okay, 2 more. I find them interesting, so I put them in here. Here we go. All right, let's see. Subtract 1. Negative 2x squared equals negative 7. Well, this doesn't look pretty, does it? That's okay. Sometimes things don't look pretty. We divide by negative 2, divide by negative 2. So x squared is going to be equal to positive 7 over 2, right? Because negative divided by negative is a positive. And then to get x by itself, you got square root. So x equals All right, well, let's use that fact that we learned earlier because you see the problem. We have to rationalize the denominator again. So times the square root of 2 times the square root of 2. Okay, excellent. So then x is going to be, you multiply what's underneath the square roots there to be the square root of 14. And then you're just left for 2. Don't forget plus and minus. I accidentally forgot that. Plus and minus. Okay. You're just left with x is equal to 14 over, or the root 14 over 2, or negative root 14 over 2. If you would prefer to write your answers as two different answers rather than that one, that's fine. Okay. F is really interesting. F is interesting because, well, okay, let's divide by 2, divide by 2. So then you're left with x minus 4 squared is equal to negative 5 over 2, at which point you would be like, all right, Bacham, we square root, and you're left with x minus 4 equals, and you're like, uh-oh. I hope that's what you're saying at least. There's a negative there. You can't take square roots of negatives yet. You don't know how. This is a no real solution type of situation. Okay. So that's what we're left with. We really have nothing else to do there. Okay. All right, that's the square root method. The square root method is very handy. It won't always be the most efficient thing to use, but it is very handy if it is efficient because it's quicker than most. Okay? All right. Third method, factoring. Okay? I know you all love factoring, but I mean, great. Me too. And so we've got this thing called the zero product property. Okay, and I'm going to type this out. The zero product property says this. It says, if A and B are real numbers, again, you're like, what's real and what's non-real? I'll tell you later. Then if A times B is equal to 0, okay, so it doesn't matter what A and B are as long as they're real numbers. If A and B equals 0, then, okay, well, think about this logically, friends. If two numbers multiplied together are 0, okay, then either A equals 0 or B equals 0 or both equal 0, right? The only time you get 0 through multiplication is if one of your friends is equal to 0. So that's what the zero product property says. And you're like, Bacham, that's really cool and interesting. How does that help us? Allow me to show you. Okay, it says solve by factoring. So context clues probably tell you then that, yeah, maybe I should solve actually by factoring here. Okay, so you can't really factor unless it's equal to 0. So let's subtract 45, subtract 45. That way we're left with x squared minus 4x minus 45 equals 0. That's an excellent first step to make. Okay? And now let's factor this. I always start by drawing my two parentheses, my x and my x. Okay. Two numbers that multiply to negative 45 but add to 4. Spoiler alert, that's 9 and 5, and I think it's a negative 9 and a plus 5. Yeah, that sounds right. Okay. And now here's where the zero product property comes in handy. The zero product property basically says, okay, if two things multiplied together equal 0, which is what we have one thing, which is this, and another thing, which is that, then either the first one is equal to 0 or the second one is equal to 0. And since we don't know which one it is, but x has to be the same no matter what, we're going to set them both equal to 0 and then solve. So algebra 1 was a fun time when you solved one-step equations. X is equal to 9, or if you subtract 5, subtract 5, x was equal to negative 5. Two answers. That means if you plugged both of those into this equation, it would work. Do it so that you know you got 100% on that part of the test, okay? All right. I'm going to skip over because of the way that my my board was set up. Let's do find the zeros of x squared minus 8x. Let's do this one first. Actually, no. Lies and propaganda. I'm so sorry. Go back. Let's do this one. Okay, this one says find the zeros of. Now, don't let that vocabulary mess you up. That basically means set this equal to 0 and solve. Okay? And you're already looking at this thinking, Bauckham, why did you do this to me? Because if you can see, the first coefficient in front of that x squared term is not 1. And so that means then that we have a 2x and we have an x. And to save time, especially because I'm on a video, I'm just going to tell you that the two things that go there are -3 and -4. You, of course, would have to work through it and reason through it to find your own answers, but there you go. You're welcome. And so we use the same thought above. Well, if they both multiply to be 0, then either 1 equals 0 or the other one equals 0. And so you set them equal to 0 and solve. Then you add 4, so x is equal to 4. Okay? The factoring is probably going to be the hardest thing for you guys because for some reason, I don't know, factoring is just a tough thing for some algebra kids to understand. So, okay, moving on. Find the zeros of that. Okay, well, that means that this equation has to be equal to 0. Okay, the number one rule of factoring, if I can teach you anything about factoring, it is this. If there is a greatest common factor, take it out. So what that means is, do they have anything in common? And this one does. This one has x in common, so you can take x out, and it factors to x times x minus 8. So that's nice. And then if you have two things that are multiplied together to equal 0, then you set one equal to 0, and then you set the other one equal to 0. Well, that one's already solved. X equals 0. Woohoo! That one was easy. Okay? Or if you add 8, then x is equal to 8. Awesome. Sometimes it really is just that simple. Okay? All right. Last one here. 0 equals 4x squared plus 28x plus 49. Okay, and you're like, oh no. There's not a greatest common factor, and there's a 4. There's so many possibilities here, Bauckham. Why did you do this to me? Well, let me help you out. If you notice, 4x squared and 49 are both squares of something. So why don't we try that first? Why don't we say, okay, well, what if that's a 2x? And what if that's a 2x? And then what if we said that was 7 and 7? And both of those signs are positive, so that means you'd have to have that. Okay, does this work? Well, 14x plus 14x is 28x, so it could, Bauckham, indeed. All right, I think it does. Excellent. Okay, so two things multiplied together equals 0, then you set them equal to 0. Oh, and if you notice, they're both the same thing, so there's probably going to be only one answer. Sure is. You subtract 7, so 2x equals -7, divided by 2, x is -7/2.
Kaya Cunningham, please call extension 8000 or report to the front office. Kaya Cunningham, please call extension 8000 or report to the front office.
Jeez, Kaya, messing up my video. That's fine. Okay, sweet. So that is factoring. Yay, factoring. That's why factoring is so important, dear friends. All right, I got two more. Here's why we use them. This is actually very applicable. Okay. A monthly teen magazine, because I know you still all order those, has 48,000 subscribers when it charges $20 per annual subscription. So for $20 a year, there are 48,000 people that order this magazine. Every time you increase in price by $1, the magazine loses 2,000 people, right? You don't want to pay $21 for a magazine. How dare you, right? Anyway. So they want to know how much should the magazine charge to maximize the revenue. Okay, well, let's find out. First of all, you have to understand what revenue is. Okay, we're going to call the revenue R of X. The revenue is going to be how much money you make. Okay, and you make, first of all, let's call X. X is going to be the price increase. Okay, that's how much you increase this magazine by. That unknown might be hard for you to figure out, and that's okay. All right. So the revenue for every price increase, well, that's going to be how many people order the magazine times the price per person, right? That's how you determine how much you own. That's how many people buy it times how much it costs. That's the revenue, okay? Well, the revenue then is, okay, well, the number of people, well, it said we started with 48,000 people ordered the magazine, and we lose 2,000 people per price increase, right? So that's the number of people. And then times the price per person, well, the price starts at $20, and it's going to increase by whatever we decide to increase it to. Okay, you there, I don't know if you can see what that is, but that there's a quadratic. You could FOIL and distribute and come up with an equation, or people, let's be real. Let's just plug that into the calculator. Okay? Plug into calculator. All right, so that's nice to have. So if you plug it into the calculator, it's asking you to find the maximum annual revenue. Okay, you see it where it says maximize? That means we're probably going to have to find the maximum. So, and I'm going to save time on here because I know you don't want to keep watching this video any longer than you have to. If you plug this equation into the calculator and you find the maximum, the max occurs at the point 2, 968,000 people. Okay? So then when it asks, okay, how much should the magazine charge to maximize annual revenue? Okay, well, this is when you have maximum annual revenue. So that means that $2 is the price increase. So if you want to know how much you should charge, well, you started with 20 and we want a $2 price increase. So that means in order to maximize our revenue, we want to charge people $22 in order for that to happen. Okay? And then it says, what's the maximum revenue? Well, that's just this part right here. Your maximum revenue is then going to be $968,000. I think I said people earlier. I totally meant dollars. Okay? It's a lot of money. But that's just the revenue. That's not the profit. Remember, you're still going to have some money that it costs to make that, whatever that is. So something to think about. Okay? All right, one more. We're almost there. It's easier than it looks. Okay, when an object is dropped, its height in feet above the ground after t seconds can be modeled by this function here, where h sub 0 is the initial height in feet, and the graph of h equals negative 16t squared plus 200, representing the height of an object dropped from an initial height of 200 feet. Okay, is shown in this picture. So for whatever reason, this guy's dropping something off this building at 200 feet tall. The model assumes that the force of air resistance is negligible. So you're like, then Bauckham, why are we doing this? We don't live in a vacuum. Well, because, sometimes we just have to see how things work in a perfect world. And fun fact, this model applies only to objects dropped on Earth. For planets with stronger or weaker gravitational forces, different models are used. So if you drop something on Mars, it's obviously going to fall differently. Or if you drop something on the moon, it's going to fall differently too. Okay, so this is only on Earth. I don't know why you're dropping something off a 200-story building on Mars, but to each his own. So for a science competition, students must design a container that prevents an egg from breaking. I'm sure you've done something like this when dropped from a height of 50 feet. Okay, so the picture applies to this up here, but now we're going to drop something from 50 feet. We're going to write an equation that gives the height of the container after t seconds. And we want to know how long does it take for the container to hit the ground. And then we want to find and interpret h1 minus h of 1.5. Okay. So it says, the first one is write an equation. Okay. Well, the equation that they gave us was h equals negative 16 t squared plus h sub 0. And now our h sub 0 is 50 feet. So the height after a certain time, it's going to be negative 16t squared plus the initial height, which is 50. Okay, there's our equation. Now we can pretty much do whatever we want to with an equation. The one that it says to, let's see, we want to know when does it take the container to hit the ground. That'd be smart, okay? We hit the ground when the height is 0. Would you agree? I hope so. So the height is 0, and we want to find out the time. Well, I'm hoping that you notice that you could solve by graphing if you wanted to. I would solve by the square root method. So if you subtract 50, you end up with negative 50 equals negative 16t squared. You divide by negative 16, okay? And then you're also going to square root, right? If you plug that into your calculator, if you round, okay, you're going to get 2 answers. One of your answers might be negative, okay? Or you might not get 2 answers. That's a lie. When you square root, you're only going to get 1. You're going to get about 1.77 seconds. If you round into 1.8 or 2, I prefer you not round to 2, but 1.77 is probably okay. So if you drop something from 50 feet, it's going to take about 1.77 seconds to hit the ground. Okay. The last part says interpret h of 1 minus h of 1.5. Okay, well, what if we figured out what those values were? So I'm going to go ahead and delete this picture just so I have some room to work. Oh, I can't, but I can make things smaller, can't I? Excellent. Okay, we're going to pretend that's over there somewhere. Okay, well, h of 1, if you were to plug it into that equation that you got there, h of 1 is going to be 34, and a height they said was in feet. Okay, so that means after 1 second, we've fallen 34 feet. And, okay, so after 1.5 seconds, you've fallen 14 feet. Okay, I'm on board. So they want to know what is h of 1, which is 34, minus h of 1.5, which is 14. Well, 34 minus 14, that turns out to be, well, 4 minus 4 is 0, 3 minus 1 is 2. That's about 20 seconds. Would we agree? Yeah, great. So that represents 20 seconds means that's how, well, let me say this. If you were to take this, these are both heights, so your answer is going to be a height. Okay, this is the distance. That's not feet, that's seconds. That's why I'm confused. This is feet. This is the distance, which is 20 feet. The distance the egg falls in between 1 second and 1.5 seconds. And you're like, well, that was lame, right? But and being able to interpret your answers and use them is a really big life skill, guys. Okay? Okay, I know it was a rather long video, but I trust that either you broke it up into some parts or, you've done your best. I highly recommend that if you didn't understand something to either watch the additional videos or ask for help. There's some stuff on YouTube as well. And whatever the due dates say online for big ideas, those are the due dates for big ideas, and I will check them accordingly. So thanks for watching. Good luck. Email me if you have questions.